Okay, the yellow sheet I gave to you has this and this on it, so let me put them side by side. This is the actual theorem. If you have some complex number in trigonometric form, there are n distinct nth roots. So if there's a fifth root, there's 5 roots. Sixth root has 6 roots, square root has 2 roots, cube root has 3 roots, all right? And the roots are going to be roots of 1, roots of 2, roots of 3, all the way to roots of n minus 1, all right? This is the way you construct them, okay? And that's all nice mathy and everything, and it's legitimate, and it's for us mathematicians, we like stuff written like that. For the sake of, I'm in Geo Trig and I'm a high school student, I don't want to be a mathematician necessarily, we're going to look at instead this part of it, and this is the four-step technique on how to do it. All right. First thing, you have to have the complex number in trig form. If it's already there, great. If it isn't, change it. All right, so do the 3-step process to change the trig form. You find the first answer, whatever the root is of the magnitude and the angle divided by the root. You get whatever you get. That's the first answer. That's part of the correct answer. All right. Then you need to find the remaining answer. So again, if there's a fifth root, there's going to be 5. So you're finding the first, and you have to find the other 4. If it's a cube root, there's 3. You find the first, you have to find the other 2. To find the rest of them, you divide 360 by n. That's how much you need to go up by for each one. And simply take the same structure here, continually making the magnitude exactly the same. Just add whatever this number is here, the magic number I'm calling it, to whatever the angle is there. And then just do it again and again and again until you get the right number of roots, then you're done. All right? So that makes much more sense when we see it in action, so let's try it. Find the 5/5 roots of 1 plus I square root of 3. So first of all, the problem, if I were to write it out, looks like this. The 5th root of 1 plus I times the square root of 3. Complex number written in standard form. Job 1, convert it to trigonometric form. So, 3-step process there. Step 1, the magnitude is going to be the square root of, and let me just make sure there's no confusion. Some people get confused. That is what we're changing to trigonometric form, not the 5th root, just the complex number inside. All right, so the magnitude is going to be the square root of, we're going to square the 1, and we're going to square the square root of 3. Again, ignore the I when you're squaring things, when you're trying to make trigonometric form to find the magnitude. So, that gives me the square root of 4, which equals 2. Step 2. Alpha is going to be the inverse tangent, absolute value, so positive. Again, the imaginary part, which is the square root of 3, not including the I, divided by the real part, 1. If we look that up on our sheet, the inverse tangent of the square root of 3 is 60 degrees. By step 3, we want to find theta based on a quadrant. A positive 1 takes me to the right, and a positive square root of 3 takes me up. If I'm going both right and up, that's the first quadrant. In the first quadrant, theta is equal to alpha. So just transfer alpha down there. So the trigonometric form of our number is going to be 2 CIS 60. So that's where we go first. So I'm going to add the 5th root, and I'm changing my trigonometric form, my standard form here to 2 CIS 60. That's job 1. Once you've done that, now we're going to write the answer. And the answer is simply the root of the magnitude. So basically, if you just ignore that, that's what that is. So just transfer that down. And then I'm going to put CIS, and then I'm going to take the angle divided by the root. 60 divided by 5 is 12. That's one of the 5 answers. Okay. Now the rest of this process is to find the other 4 answers, and we need to find a magic number. I think magic number should be purple. All right. Magic number always 360. Divided by the root. 360 divided by 5 is equal to 72 degrees. What I'm going to do is I'm going to take the angle 12 and continually add 72 degrees until I get 5 answers. Right now I've got 1 answer. So the answer is going to have this structure. The fifth root of 2 CIS. Fifth root of 2 CIS. I have to extend the page here. Fifth root of 2 CIS. Fifth root of 2 CIS. Every answer is going to look exactly like that. I've got the one I'm supposed to have, 2, 3, 4, 5. And then I just take whatever this angle is, plus 72, plus 72, plus 72, plus 72. So 12 plus 72 is 84. 84 plus 72 is 156. 156 plus 72 is 228. 228 plus 72 is 300. And there's my answers. It didn't specify a form to be left in. Whenever it says that, I assume trigonometric form, because that's what you get to first. If it specifically says, write the answer in standard form, then cosine of 12 plus I sine of 12 gets some decimal approximations. So they'll just be decimals at that point. So that's the whole process. This changes. This is always 360, but the root changes, so it changes that number. So it gets you the right number of answers. If I went 72 more, 372 minus 360 makes 12. So you got the same answer you've already gotten. So you're going to be repeating yourself at that point. So only go as many as the root. So root is 5, 5 answers, stop.